So in the next hour and a bit, we are going to take you through sort of a workshop, it's called, which means it's just a little bit more informal. And we're going to go through an introduction to the common domain model. This slide was made about 2 minutes ago. A brief discussion on CDM governance at FINOS and the story behind CDM coming to FINOS. Repo and collateral markets and CDM use cases in those. How to get started and demo of using the CDM for repo and collateral. And Q&As if we get to them. So the first bit we're going to talk about is this introduction to the common domain model. CDM 101, right? Or CDM in 7 parts in 15 minutes. So I'm going to start a timer and see how fast I can get through this. So we're going to talk about an introduction to the CDM. CDM design principles, the structure of the CDM, how it's presented to users, events in the CDM, the product model, qualifying functions, and key takeaways leveraging and shaping the future of CDM. The reason for these titles will become clear later. So, financial markets have a problem. Lots of you have seen this slide before, an oldie but a goodie. Parties, institutions, entities, vendors, everyone, every entity in these financial markets shares data in different ways and also changes the data. In different ways when they store it and persist it. CDM solves this problem. How does it solve it? Well, I'm going to use the CDM pitch here. The CDM is a model for financial products, trades in those products, and the life cycle events of those trades. It is an open source standard that aligns data, systems, and processes and is available as code in multiple languages for easy implementation across technologies. That's it. Just commit that to memory. That's what the CDM is. That's the little blurb on the GitHub page. And there's a lot in there which you can learn about as you learn about CDM. This is at the level, this is not obscure, kind of deep in the technology, deep in the database. This is how, operational staff or traders, we all call things different things, and we shouldn't. So, the CDM design principles. So the CDM is built on 4 key design principles. One is normalization through abstraction of common components. So across the industry, we think all the trades are very different. But you can break everything down to cash flows, and that's what quants do. So why can't we just break things down into simple building blocks that we put together to make our more complex products? That's what we do in CDM. Composability, where objects are built from the bottom up. So we have reusable components in the data model, which are put together to make more complex things. Mapping to existing industry formats for compatibility. Now, when we first started the CDM, I thought it would be really nice to be the CDM brand new. We don't have to worry about the existing infrastructure, and people will just adopt it, won't they? Well, that was never going to happen. So we have to integrate with other existing industry formats. Notably FPML, but there's been work done on FIX, ISO 20022, all these other standards. Really important to get the data from other systems or the data from CDM into other systems. Embedded logic to represent industry processes. So unlike a lot of previous models that have attempted to do what CDM is doing, the CDM has functions in it, and functional code that describes how we change the data object, how we change the trades over time. Crucial and really, really flexible. And this gives the CDM its flexibility and allows efficiency and makes it more widely applicable. Right, where are we? CDM structure, number 3. How are we doing on time? Okay, I'm 3 minutes in. This is good, because there's a lot more to come. CDM is made up of data types and functions that are arranged into namespaces. Now, what are namespaces? Well, it's a fancy name for the files you'll see in the GitHub repository. So that's just how we've chosen to arrange the CDM. So if you look at the GitHub repository, there's all these files. Those are the namespaces. And in there, each file, we have data types defined for defining things consistently. So we have price, and we have within it units, and then we define units as currency. And some of those are broken down to very basic types like strings or enumerated lists or numbers. This is where we control and constrain the model at its very basic atomic level. And then we have functions, which I just mentioned in the CDM, which change or check data to allow business processes to be built. So there's an example of a function, which looks like it's from the collateral section of CDM, which checks the country of origin of an asset. Okay, events in CDM. Now this is where my slides, they really go up a notch now. Wait until you see these. Okay, workflow step. So the workflow step is the highest level of the CDM event model. This is sort of how any business process or business event in a workflow is controlled. So it contains a business event, if it's accepted, a proposed event if it's under negotiation, or a rejection flag. It includes approvals from parties, timestamps, event identifiers to allow lineage to previous steps and things like that. So the workflow step is really where we say we're going to propose a new trade and you can say yes or no. So that's the workflow step level of the CDM, or the event model in CDM. Business events, which I've just discussed, so they're what are being operated on in the workflow. Business event, think of it like a life cycle event that happens to a trade or some other piece of data in the model, composed of primitive instructions. So talking about those building blocks, the primitive instructions are effectively the building blocks which the CDM is made of, that basically change the trade from one state to another. So this is the business event that's changing. So think of it, new trade, increase, decrease, novation, those things that we talk about in financial institutions a lot. And as well as that, a business event can have loads of instructions together. So if you think of a compression where you take loads of trades that fit some criteria that you're aggregating together, and you say, well, I want all the trades from that counterparty that are in this product that are dated this way. Let's compress them all together. What are you actually doing? Well, you're closing out maybe 100 trades and you're creating a new trade. That's what you're doing. So you have to have 100 closeouts and one new trade. And that's how the business event can have lots of instructions in it. So that's an example of that. The primitive instructions, which are inside the business event, functional building blocks used to compose business events. Each instruction describes fundamental change of state, transitioning it from a before state to an after state. And that's sort of, the instruction just tells you what we want to do, how we want to change the trade. And then trade state is what we're operating on. So think of it like the trade with a little bit extra. So that represents the state of a trade at each stage in its life cycle. It contains the trade, state, history, reset history, transfer history. Trade state is a fundamental input and output of any state transition in the event model. Okay, halfway there. This is a really great slide, actually. No, the trade is the top level of the product model. If we think of product model, product and trade, right? So we have this trade object, and within it, there's things that you typically need on a trade. So you have parties, you have collateral, you have contract details if you want to put a legal agreement against the trade. You might have account details. What have you got inside? Trade identifier, important for trying to lineage as to where this thing came from, and then trade dates. But the key bit related to the product is this thing called tradable product. Now, what's a tradable product? Well, the tradable product takes a product as defined in CDM, which is a bit like an instrument, just a thing, a security or something like that. And it also has this trade lot type as well in tradable product, where the prices and quantities. So we take a price and quantity and say, we're buy 100 shares at $100. So that, and the definition of the product itself, that's the tradable product. It's the thing that you're going to be transacting, that the parties at the trade level are effectively transacting. And then we go into the product. Now it gets even more complex. Product has indices, foreign exchange, commodities, baskets, and securities. which are sort of basic instruments and ways to define them with common data types and attributes that you'd expect to define some of those entities. And then we have contractual product, which is where things get a lot more interesting, where we can define more complex products. And we'll see an example of this in the repo presentation later as well, but also in derivatives. So within the contractual product, we have these things called payouts. And payouts are the fundamental building blocks for defining products. We have commodity payout, we have credit default payout, we have interest rate payout, asset payout. We also have option payout. So if I'm creating an option, or I'm, say, creating an interest rate swap, I'll put two interest rate payouts in my payout section, and one will be maybe fixed, one will be floating, and that's my fixed floating product defined. And then above that, I'll say the fixed rate price and the quantity of the notional, and then I'll have the parties and stuff, and that will define my trade product, or my trade fully. Now, the reason why I've called out option payout here is because in an option, for any option, you have to define the underlier, right? So how do we define the underlier in CDM? We define it with the product. So it's all circular. It all goes back to the start. So you could define a very complex contractual product with a commodity payout and an interest rate payout and a credit default payout and maybe, I don't know, a basket or whatever you want. You could make something really complex at the product level, and then you could trade an option on it using the CDM. It's fully modular, and we can get all that sort of complexity if it's needed, Okay, so qualifying functions related to what we've seen. So remember, we have the event model is components, that smaller components that define business events. We have the product model where payouts define more complex products, okay? So there's only composable building blocks of products, trades, and events defined in the CDM, right? So to label something as a trade, as a trade in a particular product, we have to look at the pattern. We have to look at the trade and say, what does it look like? Has it got two payouts in it that make it look like it might be an interest rate swap? And that's how we do it. We do it as code. So we define these functions. So on the left there, we have the function that defines qualifies an interest rate IR swap fixed float. And it basically does exactly what I just said. It finds a fixed float payout and another fixed float payout, calls it a fixed float. It looks for one payout that's fixed and one payout that's floating, and then stamps on the trade in a field that it is a fixed float swap. Now, why is this interesting? And this is often misunderstood. In CDM, we're doing that after the fact. Why are we doing that after the fact? Because that little label there that says, where is it? Interest rate, IR swap, fixed float. That's from the ISDA taxonomy. That's just one taxonomy. There's loads of taxonomies. It could be a CFI code. You could stack up hundreds of different identifiers and product labels. So you shouldn't really be led by the product labels. You should let the data define what the product label is. So you can write code in the CDM for all, and we can have qualifying functions for many different taxonomies. That's a key principle. And we can do the same for things like life cycle events. We can look at the pattern. What's actually changing? What have you been amending in the trade, in that business event, and define it as such. Right. Close to 13 minutes. Key takeaways, leveraging and shaping the future of CDM. So I'm going to reiterate, because it's all encapsulated in this elevator pitch, which I think Amy was possibly the author of back a long time ago, which features on the GitHub page. But the CDM is a model for financial products, trades in those products, and life cycle events of those trades. It is open source standard that aligns data, systems, and processes and available as code in multiple languages for easy implementation across technologies. Composable, normalized, modular. Building blocks are put together to make more complex things. go to the GitHub page and the documentation. It's all accessible there from cdm.finos.org. Get involved. I was very inspired by Kelsey's speech. I'm nearly inspired to take my suit off, but very inspired by Kelsey's speech, where he said, get involved, shape the future, get involved, be at the ground level. And that's what I've always said about CDM to people. Even smaller companies who think, oh, we're led by the bigger institutions. No, you make the standard the way you need it for your and make the community follow you. So that's something that people should really, really think about. Right, so that was 15 minutes. You're probably thinking, what was this guy talking about? Never fear, and Jane beat me to it earlier on stage. We have a new course designed by experts and myself, editing, covering 7 topics we covered today in 90 minutes. So whatever you didn't get, I'm sure you're probably experts now after that 15 minutes, but a 90-minute course, free to register. There is the QR code. There is the link. You can get that little badge on your Linux Foundation e-learning platform. So go ahead and do that. Right, and then just thanks to TradeHeader, who did such a great job on that. And we're still working on it, and it's going to be released later this month, but do register now, and you can get that badge. Okay, so next up, I did that right in 15 minutes 42. I'm very proud of myself. Jane is going to join us on stage and talk a little bit about CDM at FINOS and the story of CDM coming to FINOS. Jane. Hang on.
But I like the safety of the podium. It's less daunting.
There you go.
So, hi. You guys heard, most of you, I hope, heard from me before, and I won't go into too much. A few things I want to mention about the history. So, first of all, Ian is being a little bit modest because he was one of the original authors and people behind the concept. I think there were 3 of you guys. You guys were called the 3 Amigos.
I was the ringleader of 3 Amigos.
So there you go. So if you have any specific questions or complaints, see Ian after this. It's all his fault. But really, I think, so a few, and the other thing I wanted to mention, this is a little bit tough for me, but also a proud moment. In the audience is my daughter, and I was thinking about this, and I thought, gee, take your daughter to work day and try to get your kids to explain what you do. And I'm thinking she's going to sit through this session and she's going to have no clue. she's out of college. So this is truly, I do think this is, very much for the trading profession, for the trading technology professionals. This is very familiar, and it really tells you, like, it harkens back to the things you were doing as a developer, as someone who wants to model complex things and figuring out how to do it. And what I always think about is, when you have your trading system, and then you have your middle office system, and then you have your back office system, and then you have your mainframe system in the back, which is what you all have to deal with, right? And none of them talk to each other, and most of the time people spend mapping and remapping things, and then testing those remappings every time a new version comes out. And that's more or less probably 80% of what one does. And while legacy in financial institutions is kind of like a real thing and it takes a lot of effort, one of the reasons we got excited about this project is because we're really hopeful that this helps address the legacy without having to, work separately from legacy. So this is really a way to normalize and kind of make things work with the existing infrastructure, but also allow you to move to the new infrastructure. And that's, I think, one of the powers of this. So just to go over the history, some of you already know, but to delve into a little bit more detail, thanks to ISDA, Ian's work, ICMA and ISLA, we have put CDM was open sourced at FINOS back in December of 2022. As I mentioned, it was a very packed event, even more people than today. And it's quite popular. One of the things that I think makes it work really well in the community right now is that we have different working groups for different parts. So if you're interested in collateral, see Amy. If you're interested in derivatives products, there's a new working group for that. You know, if you're interested in structured products, there's a new working group for that. And if you're just interested in how this technology works and you need a new programming language binding, there's a working group for that. So we're hoping that we're addressing it at different levels of the community needs, and those are quite vibrant. As you see, and we did validate this, there's at different times, contributors come in and out. We have 36 organizations contributing. There's a structure to the sort of the process of contribution. The working groups are effectively self-governed, and then there's a contribution review working group that looks across those proposed contribution and makes a decision which package they go out in. And then there's a steering working group that sits above that sort of sets the roadmap. And by the way, David Schoen ran a survey recently that said, what do you guys want to see in the next version of CDM? Which is really, again, speaks to the next part, which is crucial to us. It's about, as Ian said, it's about you, it's about what you want. And these working groups, or any new ones that we need, will do what the community needs. Oftentimes people, you know, sometimes people who are not from open source, they kind of come in and they're like, well, what are you selling me? What does this thing do? And how do you support it? That's not relevant here because we don't have a team behind us. The team is sitting right here, and it's your colleagues who are in financial institutions who will continue to contribute. So, and therefore that means it's very, as Gab likes to use the word, meritocracy driven. It's really, the priorities are what you want them to be. Now, so different teams contributed different parts, but also what worked really well for us in the past year were the hands-on workshops that we had. So Tom ran one of the workshops earlier together with us earlier in the year, and then there was an ISLA one that was run to do a specific thing. So if you guys feel that there is something you want to do and there simply isn't time in the day, or there are other ways to go about and just kind of like have a concerted effort for a couple of weeks and just get something done. And then that will be contributed. So what we're trying to listen to is what are the most effective ways for people to work with this, to try things out. And Gab said it, adoption is the most important thing we want. We want to see this working, and I'm sure that many of you who are contributing time want the same thing. And of course, when one institution adopts this and another, that's really when the power will be felt by all. So I feel like we're in this stage of, we provided a lot of hands-on this year. We provided a lot of sort of tools that can get you going so that people can more easily play with it, so you can try it out. And it's fun for me. I keep looking at different parts of the audience. I could see people trying. There's the RBC crew. There's some new crew over here from Wellington, and then there is the JSCC crew over there who just came in June, ran a POC, and now have results. So it's like all these stories are fantastic. So and tomorrow we'll have a more in-depth session about how we've tried to put together a package that enables people to try DRR, which is another working group that ISDA is running right now. And so we are really keen to put tools in people's hands so people can try it, and then this thing can go to production as much, in the relevant use cases. So that's really, in a nutshell, the story. I don't really want to take up too much time. I'm really hoping that this becomes a conversation. Ask us how to, ask us why. What do I do? How do I really, and also please share your stories, because this is how we're going to take it forward. Thank you.
Great, thanks, Jane. Good afternoon. My name is Gabriel Callsen, Senior Director at ICMA. I'm delighted to see so many of you here today, and it's great to see the agenda, to have heard already about the CDM, about the dynamics, that there is activity, different ways to get involved, that it has been adopted already. And of course, this is the starting session today, getting started with the CDM. There's more today on the agenda, later at 4:10 on CDM and collateral in particular, and there's more to come tomorrow. So just to give you a bit of background, so as Jane mentioned, this is the CDM is a cross-industry initiative between ICMA, ISDA, and ISLA. And just to set the scene, we've heard about the CDM course, how to kind of learn more about the CDM, the governance in FINOS, which is important for an open source project, but also just a bit of background on the use case in collateral markets and ICMA. Just to give you a quick overview, we have over 600 members in 69 different jurisdictions. Across debt capital markets, we set standards for the issuance of debt securities, as an example, for the trading, the secondary market rules and recommendations. There's also the Global Master Repurchase Agreement and best practices, and also principles for sustainable finance. I won't go into too much detail. The other associations, ISDA and ISLA, play a similar role in their respective market segments, but I would like to highlight the point on best practices, and this is one we will come back to, about how to implement best practices. So, in terms of benefits of the CDM, we've already heard about the journey of the CDM. Ian touched on its features, its technical features, ensuring that what you see is what I see. If you have a transaction and it's ABC, you see it as ABC, not ABD or ABX. There's different angles to this. There's interoperability. We've heard about this before on stage in the main room, about the importance of interoperability. When we think about capital markets, about derivatives, securities lending, repo and collateral markets, where it's connecting different systems from the trading, from the front office to back office to settlement systems and so on, but also simply being able to streamline processes and reduce the manual burden. Ian alluded to this earlier. There's processes for more complex products on the spectrum, whether it's derivatives, but also repos and other operations that tend to be quite complex and difficult to automate, for which the CDM provides a basis. It's also an important enabler for innovation, because for certain technologies, standardization is the prerequisite. If we think about DLT and blockchain, and this is a continuing theme, in particular in bond markets, where central banks have become involved to provide wholesale CBDC. But for all of this to work, standards are crucial, and CDM has been used as well in this context. And just to reiterate, it is the important element here. It is supported by 3 major industry associations, and it's hosted by FINOS. So, going back to the high-level industry problems and potential solutions, just to recap on the points that Ian made, looking at inconsistent processes, data along the journey of a securities lifecycle, which changes its form and shape multiple times, which leads to manual intervention, breaks, and prevents STP. But also there's a significant amount of duplicated data. The solutions that the CDM here can provide is to provide standards, so the process standard, defining in a transaction what are the different steps that happen throughout the lifecycle of the transaction, ensuring that the data is accurate, ensuring the data integrity, but it can also be used to provide a golden source. And there's different, I guess, approaches and models how it can be used. One is to implement it as by a market infrastructure or data provider that uses it as an authoritative data store. These findings or observations are based on a report by Barclays, which was published last year on the back of the repo Barclay hack in 2023. So, in terms of use cases, we've heard about it already a little bit. I think the CDM is a model that is extremely flexible. So there's a whole range of different use cases. Taking a step back and thinking about what's driving those use cases, there's, as we already heard, simply efficiency, streamlining operations. And some of this is simply when it comes to trading, automating process around that. There's also revenue growth or liquidity. From a repo perspective, what I mean by repo here, we use it in different contexts. In particular, at FINOS, it's repurchase agreements. It is to provide liquidity on an intraday basis where new platforms have emerged and new protocols are being developed. as an example. But also, regulatory compliance is critical. And there's another session tomorrow on CDM and digital regulatory reporting. One of the examples here is derivatives reporting, CFTC rewrite, EMIR, and others. On the repo side, there are other regimes, SFTR, which already entered into force before we embarked on the CDM journey, but there may be other opportunities in the US with the OFR rules for bilateral repos or SEC 10C1 for securities lending, and others focused on collateral eligibility that will be addressed in a separate session. So just to recap, I think what's important when it comes to the CDM is to think about all the different uses. So it's not one size fit all. It can be used in many different, or has been implemented for different purposes, from regulatory reporting to enhancing collateral mobility and some of the operational processes here. Now, focusing in particular on repurchase agreements, repos, and collateral in this context. Repo markets are considered also the plumbing of financial markets due to their critical importance to foster liquidity for securities financing, but also for monetary policy transmission. It is a key component. It's a market that's complex, one that's interconnected. When we look at the life cycle, there are many different, I guess it shows a bit the complexity. Repos can be term, can be open, can be based on a floating rate, on a fixed rate, and there's many different life cycle events. So the CDM encompasses all of these, not only for repos in this case, in our use case today, but also for derivatives and securities lending. So often, whether you're developing a solution as a developer, you need to, and when you look at industry guidance or best practice guides, and you will need to think how to implement this. The CDM provides all of this already in code, so it speeds up the process actually from developing a solution just by providing not only the life cycle steps, but also some of the nuances, thinking about price. What is the price in a repo? Where you have interest, you have margin that's applied. All of these definitions are embedded in the CDM. When it comes to best practices, one example we wanted to highlight today is pair-offs. So pair-offs is a form of bilateral netting. Yeah. It's part of the broader settlement efficiency agenda. It's something that we have looked at for a number of years. We published a report 2 years ago that took stock, or that identified some of the main reasons for settlement fails. One was securities not being available, the other related to matching instructions. There were a number of different solutions that were identified and that ICMA has been focusing on within the European Repo and Collateral Council around shaping. So cutting, kind of dividing a trade into smaller sizes to avoid a significant impact if a trade were to fail. Let's say 500 million shaped into 50 million, partial and auto-partialing, so automating some of the functionalities, but also allowing partial settlement, auto-borrowing, but also netting agreements and pair-offs. So there's a proposal that has been published for repo pair-offs or bilateral netting earlier this year. So it's essentially, a pair-off is a form of technical netting for bilateral repo transaction. So and this involves a post-trade process to be able to match essentially two transactions, where one party sells a security but also receives it from another party. And in practice, this means that two settlement instructions have to be cancelled and will have to be replaced with a single instruction for the settlement. So netting essentially those two transactions, very similar to processes in derivatives and other parts of the market. This is quite a typical phenomenon when it comes to rolling over transactions or repricing. As an example here, under the legal agreement provided under the GMRA, but can also be under different agreements or in different contexts. The functionality in the CDM remains the same. So the event itself is already covered in the CDM, involving certain workflow elements from initiation, confirmation, data and cutoffs. But there's more detail that may need to be specified, and the CDM can help provide the translation of those best practices into code, essentially. So when we look at best practice considerations for pair-offs, I think conceptually on a high level, it is similar to other markets. There's nonetheless a number of things when it comes down to implementation that will need to be agreed upon. For example, whether it is underpinned by legal agreement or whether it's on a best efforts basis, the types of transactions that are covered, if it's repurchase transactions only, or if it's also cash transactions, or also buy and sellbacks, the matching parameters, for example, what type of currencies for the collateral, what types of securities, rating, and so on, whether whether payoffs can be full or partial as well, and what the relationship is. If it's one security netted against another, if it's one netted against one that is similar and one that's identical, or between different securities that meet certain criteria. And of course, there's a question about limits as well, gross and net total limits, things to define what the limit is for the system to allow. The question of the relevant agents who are involved in this, which is important when it comes to the workflow and communication. Who can initiate a payoff? Is it just the seller of collateral, or is it the two parties? Who are the other parties involved, an ICSD, paying agent, and so on? What are the cutoff times and what time zone? And there's also an important question around the different messaging formats, whether it's in XML, ISO 20022, or in FIX. This is just a snapshot of certain elements to consider. The CDM can help implement those in a much faster way than you normally would when you had to do it in isolation, understanding how you would actually do that. Now, these are the considerations. The question is, how do you get started with the CDM in practice? What are the steps you need to take to start, to understand what the CDM actually is and how it works? And then how do you get from there to, for example, implementing best practices, in this case for repo payoffs, but can also be in many other use cases. Thank you, and I'll now be handing over to Tom Healey.
Okay, great. So my name is Tom Healey. Thanks, Gabriel and everyone. So what I'm going to do actually for most of the technology people here is actually start getting into showing you some real examples of how to use the CDM. And normally we have run a number of getting started sessions. They run 3 to 4 hours. Normally they're hands-on. But I'm just going to give you a little bit of a feel for kind of what are the tools that you use and how to get started. And when you do give it a try, you'll see that it's a lot easier than what you've kind of heard today, which is a lot of fairly abstract concepts of things. Let me just, a couple of slides, just to recap some of the things that were discussed. The CDM, the model that has been developed today, covers many different financial products. The reason we need in finance, I've been doing this for a long time with worked at a number of large banks and financial institutions, is that what you've heard today in the description of defining products and defining the workflow that goes on is that every institution goes about building it themselves. They go about building it their own way. There's really not that many standards out there. There's FIX, there's FPML, there's a number of messaging standards, but when it comes down to actually integrating with them, those standards, those institutions end up designing, developing it, and coding themselves. And even with this standard, you'll find that most of them don't really align very well. So that is was one of the motivations behind it. And then when you start looking even inside an institution, I've worked at, as I said, many institutions, you can take a fairly vanilla product like a repo product, and you'll find that every application developed over a series of time will all have its own different model in it. So the CDM covers a lot of different base products and derivative products. The event coverage that Ian had spoke about, this is really kind of critical. I find this very, when I joined working with the ICMA on the CDM, that instead of doing a lot of manual hard coding of workflows, or even if you use a workflow tool, what the CDM is designed around is using a instruction set. So it has an engine that processes a set of instructions. You pass in a fairly well-described set of instructions, and then the engine runs on those instructions. So you have this engine processing instructions to do transfers, to change contracts, to modify the terms, to do a maturity. So it eliminates a lot of the coding if you can go and implement it in that type of a model. So what I'm going to do today, as I said, this is not about slides. I am going to just take you through a quick step-by-step process of actually first creating a simple product type. We'll do a little workflow because we talked about the workflow example. Execute a trade. I'll show you the execution instruction. Do the trade, and then get on to canceling that. The demo that I'm going to use here, you'll be able to get. It's on GitHub. It's in my account. It's also in the FINOS account. It is a public open repo, and it's in Java, and you can download it and work with it if you'd like. Let me, before I get started with it, let me just kind of finish up with the slide pieces. On the technology side, you'll understand kind of what I'm showing here. If you're going to use Java and Maven, the only thing you need really is that Maven dependency. Once you do that, you get access essentially to the whole CDM and how to use it. The only difference between using it this way, which I'll describe a little bit with the example I have here, is whether you want to actually start modifying the model or not, right? So this gets you access and use of the production or development version of the CDM within your own application. And with that, let me quickly now move over to this. I need my glasses for this. So a couple of things I wanted to mention. You know, all the discussion about the model and so on, the CDM actually you need to think about is a code generator, a domain-specific language, right? And then a series of libraries that are used for execution. And what I found very useful when started using this was the code generator itself, right? So you actually can take a look at not this example. I'll bring this up in a minute. So this is the test example. I can show you. I have to want to show you the other code generator before. But to think about it in this context, what you do with the CDM, if you modify the model, is that you can regenerate the entire model in many different languages. So you use Java, we have a Python generator, we have a C++, C# generator, we have a DAML generator, TypeScript generator, and so on. So no matter kind of what language or platform you're working in, or what types of interfaces you may have, one aspect of what you can do with the model is you can get a version of the code and the interfaces all generated in the language that you need, right? And you can modify this model, which I'll get into in a moment here. So just before I get to this, let me just quickly show you one thing here. Again, this is about tools and getting started. So let me first just show you one thing. So for getting started, one thing I recommend actually is what we haven't kind of mentioned is that the company that was originally behind the development of the model, the working with ISDA, was a company by the name of Regnosis. And so what I kind of recommend for getting started to get a better understanding of using the model is to sign up to get access to the Regnosis Rosetta platform. The Rosetta platform includes access to the DSL files. So let me just maybe go ahead here. So this will, it's not a good example, where's my, yeah, so you'll see here that the DSL language, which is the Rosetta language, now called Rune, is how the model is described, right? And so it's a fairly straightforward, it looks a lot like classes and attributes and functions, but the purpose of the DSL is that you can describe it in a fairly common language, and then you can generate code in many different languages. There's a graphical tool in here as well, which makes it a little bit easier to take a look at what the model looks like overall. So one of the things that was discussed about the workflow model that's in here, so you can see that there's a definition of a workflow step in here. Ian had mentioned that workflow steps are built up from a business events. So you can see in here that now in the model, there's a definition of what a business event is. And as we said, events and so on are all created out of executing primitive instructions, right? And those primitive instructions come down to this set of instructions here. So I was talking about the instructions that are used that pass into the engine that will then execute, right? The other is, Ian was talking about the tradable product piece, so let's take a look at what a tradable product is here. Let me start with a trade, maybe. So you look at the model of a trade here. You'll see these as, we were talking about how it gets broken down. A trade consisting of really parties or counterparties, and then consisting of a product underneath of that. So this is the definition of the product underneath that. As kind of Ian was describing here, the details of what goes into defining a product, and they all come under your economic terms. Right, so you'll see various elements that make up the economic terms, the most important of which is the different types of cash flows and payouts. So you can combine these cash flows and payouts from this model together to create new products, and then those new products can be used or generated within the model. And once you do that, you end up with this standardized representation of what a product looks like, right? And as we were saying, there are fixed payouts, fixed interest payouts. Here there's interest rate payouts, which is primarily used in derivative space. We also use it in the repo swap space as well. So this is one tool to kind of get started. It gives you kind of a good interactive way of kind of getting a better handle and understanding what the model looks like. So I kind of recommend starting with that. From that, I'm just going to take a step back here to show you what it looks like. So I have this, mine is all generated in Java here. So this is an example of how you instantiate or build a workflow. So this will be the workflow step. So my workflow step involves here the creation or execution of a trade. So I was showing you the parties that go into the trade. Those parties get attached here. There is the elements of the execution details, like where it's executed, what platform, and so on. This is all built within this section of the model. And then there's, of course, underneath that, the product itself. So you can see how the product actually gets created. And then the details, some more details. This is the output of, or the end result of everything that you need to do, which is develop this execution instruction, right? So this execution instruction that we've now created, I said we're going to take it and pass it into an engine that actually is going to execute the instruction. That is done through the functions that have built into the system. So the model also includes these event functions. One of us creating a business event. So you'll see that this is how you instantiate the creation of this business event. and then the actual execution of this business event, which is simply through this line of code right here. So it's fairly straightforward once you do it in terms of a few different steps of actually using the functions that are there to execute the instructions. Question?
Yes. Is there any way that this can be used for reverse engineering? When you have something in a particular language, can it construct the initial model so that it will allow me to improve further based on the model? Possible?
Well, so I've done a lot of work in this, and what you generally have to do is, the best way is that to import the representation of whatever model you have, right? So this actually works very good when you want to do model-to-model mapping. There's two ways of doing it. One is, of course, you can program it all yourself. So I'll use a fixed message example. You could create a library that simply would take these fields and map them to these fields. If you model that model, you put that into the CDM and regenerate your own version, you now have an interface library inside the CDM that you can use a model mapper to map between classes, right? So you automatically get the class mappings that you need. You can do those in code, or you can actually do them within the DSL language itself, right? So the language itself allows you simply to map sets of fields from one class to another. So those are really the two ways of actually, I see of doing this. But I like the way of importing the model into the CDM, regenerating your own version, because if you need multiple languages, it's there for you. Yes?
What are the throughput issues you observe during the deployments?
Sorry, what are the?
Throughput issues.
Throughput issues. I mean, I don't know exactly kind of what the measure of, would be in like what kind of issues you would have here. There is a little bit of an issue in terms of the instantiation and the injection process, right? So it uses juice injection. So if you're constantly running this instantiation and creating of classes, that potentially can be a little bit slower, right? So there could be that kind of a throughput issue for you. I don't, yeah. Yes?
How do you control the evolution of this model, right? Because it will come to that level of maturity over a course of time in terms of adoption.
Yeah, so as I think it's been, as described, again, we have the three components, right? We've got the engine underneath it, we've got the DSL, the language, right? And we got the code generators. And then on top of that is the model itself. We talk about the CDM and all these financial products. That really sits on top of everything else, right? That goes through a constant evolution through the various governing working groups that we have, collateral, repo, and so on. And it goes through a governance process, a review process of working groups and approval of what goes into the model, right? Kind of you heard Kelsey talking about his examples you're familiar with, making a contribution. You can make your own contribution and put that into the model, and then it will go through a new release. We are currently in development version 6 up to 70 at this point, which is took about a year at this point, and now production version 6 is going to be cut in the next couple of months. All right, so we're on production version 5.17 or something at this point, and then we're pretty soon it's going to cut version 6 out of it. So that's within the framework of the CDM and its governing process, right? If you want, you can start to think about the CDM really like Python as the language, right? Python, the language, is great, okay, but it's the libraries that make it better. So the more, if you take that base product, the CDM-based product, and you start doing your own stuff on top of it, you have to, you just have to deal with the fact that a new release comes out, and then you have to integrate your changes or your aspect to the model on top of it. All right. All right. So this is the process that goes through. I'm just going to, run you a quick demo. This is more of a, I'm not making this up. We'll just do 1,000 in here. I'll put a price 8 on it. And so execute this trade. So we did this trade. I'm just going to show you what the output of that file actually looks like. So it's one of these here. So this would be this execution. So this is the output of this execution, which is in JSON format, right? And with the JSON format of this output, what we do a lot of is serializing and deserializing those objects. So moving objects around either across platforms or within the application itself in order to get it from one object to another, we serialize it and then deserialize it. And you can do that across any component of the model itself. You can take a counterparty object, right? It's a small counterparty object. You can serialize that, and you can pass that over to another application, and then you can deserialize it into a Java object, right? You can take all these, you can take your entire customer database, convert them into serialized objects, and then you can read them in when you need to. In fact, we have if you stop by the Trader X demo downstairs or in the showcase in the expo area, Trader X has a demo of CDM inside using accounts and trades and so on. And you can actually see the flow a little bit better there. So this was the result of this. If I'm still okay on time, I will just want to show you one other thing. Let me. I don't know if I'll get to the repo. I'll try it as quickly as I can here, but I do want to just kind of show you, what we do with this. Where is it here? Yeah. So this is, as I was saying, all the Rosetta files. So as I was talking about how we amend them if you want to work with them a little bit. So here's an example of an extension for integrating Swift into the CDM. So Swift is not fully integrated into the CDM at the moment. So this was something that we're working on, which is, I think you were asking the question about integrating other models into it. This is a model representation of Swift messages. If you're familiar at all with Swift, it's used for global payments around the world. Everybody uses it. Everybody interfaces to it if you want to make any kind of a payment. Here's an example of kind of representing it in the DSL. And then we have a number of different functions that we've built using Swift messaging. Sorry, here's the definition of the data types. These are the definitions of the various tags and so on that go into the Swift message themselves. So now I can generate this, like, as I said, in any language itself. I'm just going to go through one last example. You can let me ask a question if you want to. I know we're running a little bit short on time, but just to go back to what Gabriel was discussing and showing before, let me see if I can get this running here. Right, so just want to show you a little bit here. I showed you a basic example, kind of just trading example like this, but as Gabriel was describing, financial markets have a lot of complex workflows in it. One of the things that we built into the CDM is repo trading with all repo lifecycle events. So these get into a lot of lifecycle events where you're repricing a trade, where you are early terminating a trade, where you are changing the collateral or substitution of collateral on a trade. So a lot of various workflow steps involved here. So just as a demonstration, this application here is built entirely with the CDM objects and CDM workflows. So as an example, this sets up the entire trade here. I'm just going to book this trade. So the workflow steps involve a few different steps. One of them is to actually confirm the trade, which I should get a confirmation here. Yep, so we're confirming the trade is one workflow step. The transaction is formed. The output of that message.
So, John, that's it's a proposed workflow instruction.
Yes.
It gets accepted by that okay, just creating a business event, which is the new trade.
That's correct, yeah, yeah. So it's actually going through all the workflow steps that I was kind of describing there, which maybe I'll show you here. So they actually, there we go. So this was, I was showing you the execution workflow step before. What I'll do in this particular case here, let me just see, settings. I'm just going to do a new trade, and I'm going to reverse this trade so that I've now reversed it, so it's like two counterparties doing opposite sides of that trade. Just change the price of the trade here, book this trade. And then we would normally go through a pair-off process in this trade. I think it's just slow connection here. I'll just show you kind of what the results of those steps are. So we would normally go through a request. So this is the structure of a request object that we would send. So as I mentioned, you can create these and serialize them and then send them across to another platform. There is then the pair-off trade part of this process. So this is where the trades get paired off. Right. So you would see here, we normally would come in here, we would match up these trades. All right, so it actually shows me kind of what trades are available to get paired off. These were a couple of earlier trades that I did here. And those instructions, which is this, you can see here this base instruction, which is a primitive instruction definition here. This is that definition of that primitive instruction which you run through the engine to get executed. There's a couple of additional steps that go through the process. Ultimately, we get down to actually getting these trades paired off in the structure itself. Right? So very quickly, really just wanted to kind of show you the tools you need to kind of get started. There's a couple of examples just to even get started, basic application that you can actually program yourself. And then just really want to give you a flavor of something that's a little bit more complex. This actually deals with a lot of life cycle events that we deal with. Any questions on that? Okay, so like I said, did you have a question?
Yeah. So I was looking at the initial IMM for math or
Yes.
strategies like
Yes, yeah. So, the way the model works really is made up all of these components, right? And as, I don't know if it was clear when Ian was trying to describe that the qualification function. So the determination on what type of product it is actually made after the fact, not before the fact, right? So you construct this, like you could take an FPML structure, map it into whatever type of product structure that you want. When you execute it, the model will tell you what type of product you have. Do you have an interest rate swap? Do you have a, is it a foreign exchange swap or whatever type of product it is? So it will qualify the type of product after you've created it for you. But so you can create any type of product you want. There are pre-maps, there's mappings already that exist from FPML into the model.
But I think just to give you a more...
Gateways to the market, like I could use CDM to connect to Bloomberg, Trade West,
Yes.
whatever.
Yes. As a matter of fact, this goes into how we kind of use the CDM to integrate to other platforms, right? We've done proof of concept. There's nothing formalized in the CDM. Outside the CDM, we've done proof of concept for a FIX interface. Of course, there's an FPML interface available. We've done Swift. We've done, which one? ISO 22. And even as simple as if you use like the GLEI, the GLIEF database, like a web service, like to validate your LEIs that you use, we have a proof of concept to do that as well. So you can create a counterparty here, put in an LEI, and then it connects very easily to a web service. You can do a web service.
That's production level. That's in production.
Yeah. Oh, okay. Yeah. So that those and how you do that. Like if you have your own applications, that then gets into customizing it into your own space, right? So that you, as I was describing, you can model something that you have in your own environment, and you can model it in the CDM, and you can regenerate it in the CDM, and it's very easy to then map within the CDM itself, right? I mean, the only caveat is that you have to deal with versioning, right? So you get a new version of the CDM comes out, then you have to integrate it into your own environment, right? Yes?
You had a section about valuations. Can you talk about the valuation aspect?
So there is definitely as part of what we've done for collateral is that we have so there is valuation methods that are defined within the model. So the methods of how to calculate interest payments and how to do valuations, treatment of those valuations, how they get used in terms of margining and so on and so forth. All of those parameters are in the model itself, right? Just to understand what's not in the model is the actual execution of those models themselves, right? So the actual process to calculate the valuation, that doesn't exist in the model. What you have are the parameters that define how it is to be valued, and then you would need an outside engine in order to execute that.
So let's say you have a fiat derivative and you have the valuations directly coming from NCH or X.
Yes.
You could just integrate it?
Yes. That I mean, yeah. If you want to take in something as clear as just a premium or a risk factor or something of those sort, that's pretty straightforward. If you actually, a better way of doing it is take your model parameters and then use those to map to whatever outside model that you have, right? So then actually you can pass in like that structure and get it valued, and then you get the value back.
And that also includes internal in-house models we can integrate.
Yeah. I mean, if you. Yeah, I mean, if the models, if the product structure doesn't exist, then you're defining that yourself, right? You don't have to change the CDM, the model, to do it. It probably is just an issue of constructing the right parameters. Go ahead.
Usually this is spoken in terms of blockchain and distributed ledger. So what are you guys thinking about at this point?
Well, I don't know. Is there going to be?
There have been examples of the CDM being deployed on blockchain and distributed ledger, and the design principles behind it kind of lend itself to that.
I guess specific to the implementing understand
Yeah, so it's just the ICMA has a separate initiative going on, and a number of the digital bond issuers that have their own smart contracts. Gabriel is working with them on ways of integrating a taxonomy that has been developed by the ICMA into that for that purpose, right? Exactly what fields do you use from this taxonomy in their smart contracts, and a number of digital bond offerings out of the European community are looking at using it.
Yeah, but just to be clear, it's kind of a step away from the CDM.
Yes, yeah, this is,
process.
yeah.
We're doing some work on, I guess, some basic definitions, but it's not about the workflow just yet because this is still a step.
Yeah, the two are not integrated. I'm just mentioning it. Yeah, it's just a building block at this point. Yeah.
Do vendors integrate CDM? Calypsos and other vendors?
So a number of vendors have worked with using the CDM for trade flow, for execution flow. I don't know exactly who the list is. I'm not sure. Yeah.
And some of the large model libraries, again, usually vendors, as soon as the same, like bond libraries or yes, yeah.
I mean, if you have a library, you're talking about a model or an actual like valuation?
Instrument pricing.
A pricing. Well, it's fairly straightforward. I mean, you can just integrate it directly into your application, or most of these are built up some kind of distributed service, right? The idea could be that you actually pass over the representation of the model from the CDM into that service. That service, if you go see the Trader X demo, that service can then take what that model is, generate an object out of it, and then you can do your evaluation in that context. Right.
Is that slightly inspirational, or is it working? No,
well, I mean,
this is quite an important point.
yeah, no, it's been, in terms of the work we've done, it's all proof of concept in terms of its demonstration capability can be done. The DRR, which is the Digital Regulatory Reporting Engine, and the collateral work from ISDA is probably the most mature in terms of actually executing on those events.
But if the question is, could you integrate with a pricing library at the data level, data object level? Yeah, because you just show me the library. You can load it into CDM, make the relationships, and then every time the CDM is released, those relationships will persist. Understood. Okay, that's what it's asking. Yeah. No, we don't have any specific ones in mind. So
Yeah.
that's
If you have to see any of the uses of valuation, is that fine?
Yeah, just, so one other point is there's a lot of resources for getting started. There's a session that we run, which is a full training session, but we at the ICMA, we run an implementation working group that meets about every 6 weeks. We go through various examples. It's for technology, so it's actually the coding and the interfacing and how you actually use it. We run it about every 6 weeks. You can reach out to me or reach out to Gabriel and let us know, and get you on the invitation list for it. Yeah.
Yeah, and before, just to plug the next talk, it's 4:10, there's a talk about collateral lifecycle management, which Amy's going to do, which speaks specifically for CDM collateral, and tomorrow there's a talk on DRR.
Yeah.
It's like it's very hands-on, so, yeah.
Great, thank you very much.